Good morning, class. Are you ready for today's class? The topic for today is interpreting data. So in this chapter, we will look at some commonly used types of statistical diagrams like bar graphs, line graphs, pictograms, etc. and learn how to interpret them correctly and create them by ourselves. What does the data mean? Yes, let's see the learning objectives. Our objective is to identify patterns in visual data, make relevant conclusions from visual data, make predictions based on visual data. Here is a task for you. Which do you think is the best way to represent data on the size of planets? So we know the planets of the solar system, whether by giving a picture on the left hand side or by a table or by a graph. So you can analyze each one of them carefully. The picture is really interesting. The table has a lot of data. And look at the bar graph. What is given on the x and the y axis? Now try to draw a conclusion. What are the advantages and disadvantages of each one? Can you draw conclusions from each one? Which one would you prefer? Is it a bar graph or a table? So we need a lot of discussion, right? I feel bar graph would be the best way to represent the size of planets. You have learned about bar graphs from lower grades and you know what are the features of a bar graph. Let's have a recap. A bar graph is a chart that plots data using rectangular bars that represent the total amount of observations in the data for that category. Here is a bar graph and the x-axis shows planets in our solar system and y-axis shows number of moons. You know, a moon means the natural satellite of the planet. We can see our planet Mother Earth has only one moon. Mercury, Venus have none. Mars, Jupiter, Saturn, Uranus, Neptune, they have many moons. So this graphical representation gives a clear picture that Uranus has the greatest number of moons. How many? 20. And Mars has 2 while Earth has 1. So you must be able to draw a conclusion how many more moons Saturn has than Jupiter. Like that, many questions can be answered by analyzing this graph. A double bar graph or a triple bar graph. Have you come across that? In the newspapers, many informations come in this way. Here you can see, look at it closely. 3 color codes are given. Light blue shows marine, dark blue inland water, and the red color the terrestrial. Now what is this graph showing? Numbers of threatened animal species. In science you have learned some species are endangered. They face a threat. Now the graph similarly on the y-axis the number has been chosen and on the x-axis you can see mammals, birds, reptiles, amphibians, the different types of animals are written. So a double bar graph will give you the idea when two categories are displayed at the same time. That means it is used to display two sets of data on the same graph. So a triple bar graph will show you 3 sets of data at the same time. Line graphs. In term 1 you have learned a line graph for direct proportion and a curve for inverse proportion. So you have come across different types of graphs. Similarly, here also we have an x and a y axis. Looking at the graph, you will be able to interpret the graph. I have shown some examples here. Coming to pictograms. From smaller classes, You might have come across pictograms where pictures are used. Look at this carefully. One cupcake is equal to 6 cupcakes. And this pictogram shows the sale of cupcakes in a week at Mr. Baker's. So Monday it shows 5 cupcakes. That means actually the actual number will be 5 times 6. 30 cupcakes were sold on Monday. While on Tuesday it has been represented by 2.5. So 2 cupcakes will represent 2 into 6, 12, and half of a cupcake is for 3. So 12 plus 3, 15 cupcakes were sold on Tuesday, and it goes on like that. So we can calculate the total number of cupcakes sold in a week also, and which day the sale was the maximum and which day it was the least. Like that, many things can be interpreted from this pictogram. The practice questions in the textbook are for you to look into that whether you can apply all your learning. Thank you.